with so many choices at your disposal, it's quite easy to get a thing. It's called, here, let me post that link to you as well. What's it called? AWS periodic table. It's what I like to call analysis paralysis. Okay, with so many things at your disposal, how do you know what to choose and what best fits your use case? If you're curious, I mean, this is one of those links that I think you should bookmark and you should check it out yourself, because you click on anything such as step functions, which is a way to kind of decouple an application. So there we go. Yeah, so it takes you to a page, blah, blah, blah. It's not much more than just a kind of a gimmick, but it does tell us where things lie in the core architecture stack. So as a refresher and a knowledge check, I want us to go over how databases that can be classified, because there's a lot of them. It's hard for us to know which one to choose. And the use case, again, like I want you to go from when you have a hammer, everything looks like a nail, to more recognizing the design options and help pick the right service for the right job. Okay, that's what we're here to do. Okay, so to do that, well, we're going to start talking about this. So, okay, I think about, so it's worth going back over this. Okay, so as a bit of a knowledge cap, we were talking lastly about what? What was the last thing we were looking at? Okay. We've been looking at one kind of database in particular more than anything else. And it's the clues on screen. It's right there. So relational databases. Yeah, you're right. So they've been around for a good while. They've been around 50 years or so. And the main feature of a relational database is that the data is organized in, or they're arranged in two ways. Two ways. If I'm going this way, if I'm going this way. Tell me what would I find at the very top? How would I describe this in a relational database? Clue, it starts with C. And we've got columns, which leaves us with what going down on the left. Or the other side if you lefty flip rows. Exactly right, Shay. Yeah, exactly right. So that's pretty much how it breaks down to, and it's no different to an Excel spreadsheet or something to that effect. So another important feature of these relational databases is that they use something in order to help us, I don't want to say the word, but to access or to insert or to update or to delete records. And if you looked at that as an acronym, so create, read, update, and delete, what's better known as a CRUD. And you'll come across that again here and there. How can I perform CRUD? Create, read, update, and delete on something like a relational database. How can I do that? How can I something on a database? So what I'm looking for is a kind of language which not so you're overthinking it. That's you're right, but what is that part of, Shay? You're absolutely right. It's even easier than that. It's even easier. What's that today? Apologies, I'm a little bit poorly. We're talking about, I'm going to trigger your memory. We're talking about SQL. Okay, so SQL is how we refer to this. Is how we perform, how we do anything to those records. Now, the internet did something in the 90s. What happened in the 90s was the internet, it became cool. It became really, really popular. A lot of people started using the internet. So if something becomes a lot of, well, what happened was we hit certain limits. Scaling happened like never seen before with relational databases. Not only this, but we weren't using very simple data anymore. We had larger and more wider variety of data types as well on the internet. So what we have then is this need for a relational database management system, okay, an RDBMS, which I hate to say, but just basically an RDS. That's not simple enough anymore. That just won't cut it, which led to the development of new designs. And actually, can you tell me something? So if this is a SQL database, what is the counterpart? We have new designs. Has anyone heard of another kind of database that we're going to talk about in a bit? So SQL is one of them. We can talk about a relational database or a SQL database. Now, go figure. What's the opposite of something that's relational or unrelational? No, there's one called a non-relational database. Exactly right. Yeah. Or they just call them NoSQL. I think that's kind of the going phrase now, but you're absolutely dead on. Yeah. So it's kind of confusing as it is, but it does kind of convey the idea that we can deal with data that's not so structured, and it deals with it more flexible as well. It was, I don't know who coined it, some Italian or something. We'll look at this later. But the main difference between relational and non-relational, or SQL and non-SQL, is the way that they store data and the way that they query it. So an example of making a choice between them. So take a banking transaction. Okay. So banking, we said, is really, really important for transactions because we're dealing with money and people like to cling onto that like dragons. So if you're trying to make a transaction like a financial transaction in every customer's bank account, you always need to be sure that they are consistent. And if there's an error, you're able to roll back as well. So in that kind of scenario, okay, some kind of financial institution would have, or FinOps, whatever you want to call it, financial institutions are going to use RDBMS or SQL databases because they force it to be quite consistent as well. So if information is not available, then what's going to say is, well, we need you to do something. We're expecting you to give us something. Just so it will always force you, and this will make more sense when I'm mentioning it now, it will force you to store null data or something, or some value. So push comes to shove, you will always have to have something inside of a row in your relational database. Okay. So for example, so when it comes to social media profiles, which can have hundreds and thousands of attributes, if you think about social media, what are some of the attributes that you can get? You've got a person, how can you describe a person? So what are the qualities, what are the attributes you might expect to represent someone in a database, especially like a social media database? Yeah, throw some suggestions at me. So in terms of attributes, I'm thinking, well, first of all, how can I take this from this nameless person to someone more recognizable? What things can I describe them with? Absolutely. Okay, so bio, let's break this down because that's I like it, but it's way too big. So I need to know. Okay, we can go for okay. Let's go for job role. I like it. You're absolutely dead on with bio, but that's kind of like a marketing tool. So name absolutely. Even I can go first and last name as well. So I'll say first and last as well. Name. How do I know this person is able to actually get social media? I think there's some kind of regulations or some bans around young people as well. Think about that. You must be this tall to enter this ride, that sort of thing. Okay, you know what? Let's go for it. Let's put that in for now. I like that picture. So, how old is this person? Where do they live? Whatever you want. Okay, so preferences, that kind of jazz. Let me circle back to picture in a second. So, does anyone remember? And I was reading about this yesterday. I don't know if it's just me, but do you remember a thing called Google Plus? Does anyone remember this product? I bet you've not thought about this in a long time. Maybe some of you never heard of it. Does anyone remember Google Plus? Nope. Okay, well, that's probably why. Yeah. They probably don't want you to remember because it was an absolute monstrosity. It was a failure. It was terrible. It was terrible. So this was Google's answer to, I want to say Twitter or Facebook or something between. It was kind of that mid-noughties period. Yeah, so 2011. And it was an attempt to change the, yeah, like blah, 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 blah. It was terrible. It was terrible. It was terrible. It was terrible. And one of the things that he actually failed upon was the kind of pushiness as well behind it because they really forced you to integrate with everything. You couldn't use YouTube if you didn't have Google Plus. It was just terrible. And when you were signing up for Google, oh, yeah, so by the way, they discontinued it. That's why there was news about this the other day. Like they just said, nope, it died. Yeah. So with this, they were forcing you to give more information than Facebook or Twitter, the other ones. So they were asking you a lot of information, which let me ask you, like, are you willing to give that information to absolutely everyone you meet? Probably we're probably used to it now, but back then that was still an issue. So that was one of the shortfalls from this because they used the relational database and it really needed more information for you. Okay, so Shay, perhaps this other example. Have you ever tried to apply for a job where you're ready, you read through the description, Shay, you have your CV in your hand, you're ready to pass it over to them, but what happens is they ask, actually, can you not give us your CV? Can you just write it manually, each and everything? Have you ever had that happen to you before? Yeah. Yeah, it's an absolute, yeah, I hate it. So what happens is, what's the likelihood of people doing this 100% through? What's the likelihood of actually you taking that seriously? NHS. We complain about bureaucracy in the UK, but it's worse in other places, believe me. Oh, when I was in the Emirates, it was just insane. So what happens is users, well, you're not going to fill in all of the information, are you? If you're anything like me, my eyes, what they do is they scan, okay? They scan through the form, they say, okay, what am I looking for? I'm looking for the ones that have this little tick in the corner. What does this little tick next to, what does that tick mean? When it has the asterisk next to the form. It's mandatory. Exactly right. Yeah. So that's kind of the ones that I have to fill in. The rest of them, less likely. You with me? So some users are just going to write their email address. Others, yeah, okay, maybe you add more details. Maybe actually, I've got time. I'll give you my email address, my education, my favorite color, my favorite, what's for dinner later, my favorite drink, blah, blah, blah. So in such cases, you don't want a non-relational database. Sorry, you want this way. You don't want a relational database. What you want to use instead is a non-relational database. Okay, that's going to work better with this because some people are going to add everything. Some people can add certain items, and some people kind of in between. Yeah, it depends exactly on the user too. So if I have, for example, so first name, so second, I'll say name. Say that's just easier. Instruments and country. I'm thinking of a band. I quite like the Foo Fighters, so I'm going to go for the Foo Fighters. If you know them, we've got people like Dave. Okay, so Dave is the lead singer from the Foo Fighters. Come on. So Dave Grohl, and he's the vocals, he plays guitar, but also vocals, and he's from the USA. Okay, so that's completely filled in. Okay, so here I've got the first name, last name is from the country of Dave. That's great. Maybe the next guy I have Pat. Same goes for Pat. What's his name? Pat Smith or Smith or something. I can't remember. He's the rhythm USA. We've got Taylor Hawkins. He's the drummer. Okay, so USA, they're all like American, blah, blah, blah. So in this kind of relational database system, I have all the information. Yeah, they're all filled in. But imagine there's a new person. Okay, there's an alien joins the band, alien. So he plays the bass, okay? But he doesn't come from a country because he's an alien. So I can't answer this properly. What I'm going to say instead, because it's a relational database system, because it's an RDS, I have to say something. I'm going to leave it as a null, okay? So I have to keep some value in there. That's one of the hallmark characteristics of an RDS, of a SQL database. You need to fill in that missing information with a null value across all columns. Whereas with a non-relational database system, with a NoSQL database, that column just doesn't exist. It's fine, okay? Is that going to make sense? Are we happy with that? Yeah. So following this, I just want to clear, still that thing again where I've drawn on the this card. Happy days. Yeah, so I just want to recap as well. So there's two kinds of consistency models as well. Do you remember what I mean by consistency model? I'm just doing a quick knowledge check, make sure we're on the same page. So in the context of databases, we want to make sure that transaction data, the consistency, it involves restricting the ability to change or modify data in ways that are unexpected, in unauthorized ways. So when data is being written to the database, it's going to match a certain set of rules or predetermined constraints or rules because the square peg goes in the square hole, that kind of thing, right? So these rules, they need to be verified. And the checks that they have to go through, they have to be passed before the data can actually be accessed by the users. Again, that's quite an important thing. It's a subtle thing we sort of tuck under our arms and say, yeah, sure. But it does actually change a lot of things. Okay, so this process does two things. One, it ensures that data has integrity. Okay, so when we talk about data integrity, that means the information that's being stored is actually going to be trustworthy. Okay, or accurate. I don't know what happened to my handwriting, but just completely fell off the handle there. Currently, there are two kind of data consistency models. I'm wondering if anyone is brave enough to tell us. Okay, a little bit of a clue. One starts with the letter A and was popular in the 60s. So that's one of the features. Yes, but also so let's go for the models. You're absolutely dead on. That is one of the features. So let's split into two parts. We've got the first one, which by the way, they're acronyms. Okay, so as a reminder, they're acronyms. So remember when database sizes were measured in megabytes? Okay, like tiny little things. We did have requirements like enforce strict consistency, but we're not talking about megabytes anymore because storage now is a lot cheaper. Databases can be way bigger. You may have heard of a megabyte or a gigabyte, but what's the biggest byte you've ever heard of? Has anyone heard of something bigger than a gigabyte? So we've heard of megabytes, we've heard of a gigabyte. What follows the chain? What's on this? Absolutely, I don't know the exact numbers, but terabytes big now. Yeah, I think we're coming to a point where it's common to have terabytes at home. But we can do bigger. There's two more that I know of, at least that are cloudy, and then we get into silly numbers. There's one called a petabyte, and then one which is just ridiculous. It's called an exabyte. I think the whole internet, everything online, is about 14 of these, so that's just otherworldly. But a petabyte is kind of pushing the limits now. Okay, so we've gone way deeper in the amount of data we can have. So for this reason, storing data and making sure it's kind of integral, it's very difficult. So this first model, which I'm going to remind you, please start with the letter A. Okay, so this is a way to making it compliant to something like that. Okay, this is a model to make it maybe that'll jog your memory. Okay, so let's go for A. So for an operation to be considered A, it has to make sure that all the transactions, they either do one of two things. They either succeed or they fail. Okay, so if one of these transactions fails, and what I mean by transaction is I mean actually modifying or updating a record. So if one of those fails, then all operations should fail and you have to go back. Okay, you have to roll back. Can you imagine what would happen if you went to an ATM and the machine just gave you the money and it didn't deduct it from your accounts? That'd be great, but it wouldn't happen. So this is what we call atomicity. Okay, so it has to pass or nothing. What about the second one? We did cover it a while ago. That's why I want to rehash on it now. So C, these are where transactions, they're kind of isolated and they don't really contend with each other. So access to data from multiple users, that's going to moderate it to avoid contention. So what does this mean? Does anyone remember what this is? Yeah, absolutely, consistency. I'm not going to write it here, just trust me, it's consistency. Yeah, okay, now we're with me. What about this one? Okay, so in this one, transactions are kind of, they're I almost said it, but they don't fight over each other, okay? So access to data from multiple users, yeah, isolation, exactly right. Which means D, the last one, it's even after a transaction that's completed, any changes to the transaction should be durable, exactly right, Durable, consistent, isolated, and durable, exactly right. So even in like power failure, whatever, it's still going to hold points. So exactly right. If performance wasn't a consideration, ACID or the ACID model, fantastic. It would always be the right choice. Okay, that is the right choice. But like I said, if performance wasn't an issue. But now with all your TikToks and your Gen Z gratification and all the rest of it, we need applications to serve a like a worldwide client base. And data types are much larger. We need performance like never before. So put your architecting hat on for a second there and realize, okay, so ACID, it's extremely safe. Sure. So we've gained security. It's extremely safe. But what's the problem? So at the expense of what? Because it's atomicity, because it's consistent, because it's isolated, because it's durable, because it's so rigorous in the way it does, why can't we use it for all of the data types? Again, because data's getting bigger and bigger and bigger and bigger, is it easy to scale up and kind of to match the way that we have so much data at our disposal now? We've lost something. We've lost scalability. We've lost performance more than anything. Okay, so speed, basically speed, which is why we have the second model. Okay, so the second model is this. In most of the other one, the NoSQL databases, ACID is not used. Not Angelita, you're just where we want you. Okay, we're just doing a catch up. We're just wrapping up here. But good morning to you. So, okay, as long as you can hear us, that's fine. So, what we're saying is we've got ACID as one of those consistency models. The second one, so these databases have loosened up, okay, such as the data freshness, the consistency, what have you, what have you. So, some exceptions for this is when we want something that's a bit quicker. Okay, so it breaks down as this. B stands for a thing called, and I'm just going to write it because it takes forever. Basic availability. Any guesses what A? Any guesses what the rest of it was? So it was between the two camps. You're either looking at something which is what's the other one? So I'm talking about this, and this. Okay, so we're talking about something which is basically base. So basic availability, soft states, and eventual consistency. Yeah, I know that's a while ago. So to go through this idea, like it doesn't have to be so good anymore. Okay, so for the majority of time, it's basically available for the majority of time, but not necessarily all of the time. Okay, it kind of emphasizes more the general availability without guaranteeing the consistency of the data replication. Okay, just get it out of the way and be optimistic as we get through. Soft states. So the database, it doesn't have to be right consistent. So when we'll talk about in a second called a replica, it doesn't always have to be mutually consistent. When you do a backup, it's called a replica. It don't have to be mutually consistent, okay? So for example, a system, I don't know, it can be a few milliseconds if you, whatever. In any case, if you have slightly different results, but if you rerun the query a bit sooner, okay. Anyway, eventual consistency. So that's where eventually the data will be retrieved at a later point. Okay, if that makes sense, I think we're good to go. So we're going to go into fresh waters now. So that's kind of databases at a glance. So where we're going to go to today is looking at RDS.